Now let's begin with a very interesting topic, and that is study of some compounds. In this topic, we are going to study about three things, three compounds, and they are: first, we are going to touch SO2, then we are going to handle H2S, that is hydrogen sulfide, and then we are going to see the preparation of sulfuric acid, and we are going to deal with in detail for all these three molecules or compounds. To begin with it, let's take sulfur dioxide, SO2, a poisonous gas, highly poisonous, always stored in the form of a liquid. It can easily be liquefied at -10 degrees Celsius and 2 atmospheric pressure. This gas, even though it is poisonous, has a large amount of application in various fields such as industries, in the manufacture of sulfuric acid by the process called contact process. The sulfur dioxide gas occurs only in the free state. In volcanic areas, even the gases which comes out in industries, the pollutants, whereas it can also be obtained when an ore of sulfur, that is zinc blende, is heated or oxidized. It will give out sulfur dioxide. Now let's see how to prepare sulfur dioxide. It can be obtained in both the ways, in lab also and in a larger scale in industries. In case of lab preparation, we can use any metallic sulfite, any bisulfite or copper. If you are taking a metallic sulfite or a bisulfite, you can use dilute acid like dilute sulfuric acid or dilute hydrochloric acid. But if you are taking copper metal, you have to use concentrated sulfuric acid. In case of metallic sulfite and bisulfite with dilute acid, you just require warming the round bottom flask. Whereas if you are taking copper with concentrated sulfuric acid, you have to strongly heat the round bottom flask. Now, in case of preparation of sulfur dioxide, when we take metallic sulfite or bisulfite and treat it with acid, that is dilute acid, either H2SO4 or HCl, we will be getting the respective salt along with water, and along with that we will be getting sulfur dioxide gas. Let's understand this with an example. To begin with it, we can take sodium sulfite, Na2SO3, treated with H2SO4 dilute. We will be getting Na2SO4 plus H2O plus SO2 gas, indicate by an arrow upward. Another example which we can select is sodium bisulfite, NaHSO3, that is 2 NaHSO3 treated with H2SO4 will give you Na2SO4 plus 2H2O plus 2SO2 gas. We can also do it with HCl, that is dilute acid. We select Na2SO3 treated with 2HCl will give you 2 NaCl plus H2O plus SO2. Similar manner, we can take bisulfite, that is NaHSO3 plus HCl will give you NaCl plus H2O plus SO2. We can also select calcium sulfite, that is CaSO3 plus 2HCl will give you CaCl2 plus H2O plus SO2. But make a note, we cannot use calcium sulfite with sulfuric acid. Reason? It will form calcium sulfate, and this calcium sulfate once formed is not soluble and it will stop the reaction. It's a white precipitate which will not go further for any reaction. It will stop the reaction. So we should select only HCl with calcium sulfite and not H2SO4. Now, the main lab method is using copper turning. Take a copper turning in a round bottom flask. To this we add concentrated sulfuric acid and we strongly heat it. We will be getting copper sulfate, that is CuSO4, along with water, that is 2H2O, plus sulfur dioxide. Once sulfur dioxide comes out, it is passed through a drying agent. The drying agent which we have selected is sulfuric acid itself, concentrated sulfuric acid, which will remove moisture. Other drying agent we don't take it. Reason, it will react with SO2. So after removing it, that is moisture, this sulfur dioxide gas, it is heavier than air. So it is collected by upward displacement of air. Why not over water? It is highly soluble in water. 1 volume of water dissolve 80 volume of SO2 at 0 degree Celsius. Now, why it should be collected by upward displacement of air? Reason, it is 2.2 times heavier than air. You can verify this by finding out the vapor density. How to calculate vapor density? It is molecular weight divided by 2. How to take out molecular weight? Add the weight according to the formula of the gas. S plus O2, that is S plus O plus O. S is 32, oxygen 16. So 32 plus 16 gives us 64. 64 divided by 2 is 32. So the vapor density of SO2 is 32, whereas air is 14.4. So it is approximately 2.2 times heavier than air. So collection will be upward displacement of air. Now let's see how we can prepare sulfur dioxide on a larger scale, that is industrial method. In case of industrial method, we have two ways of preparing it. One, by going for direct combustion. Sulfur is burned in excess of oxygen, giving us sulfur dioxide. But there is some impurities which are formed. That is formation of SO3, which is acting as an impurities. Other method is combustion of, or you can say roasting of, certain ores of sulfur, metallic sulfide, like zinc blende, copper pyrite, iron pyrite. The reaction for that goes as follows. 2ZnS, if roasted in excess of oxygen, that is 3O2, will give you ZnO, that is 2ZnO plus 2SO2 gas. Similar manner, if you take copper pyrite, it is 2CuFeH2 plus O2 will give you Cu2S plus 2FeS plus SO2 gas. If you take iron pyrite, that is 4FeS2 plus 11O2 will give you 2Fe2O3 plus 8SO2. Now, as we had already discussed, this SO2 is highly poisonous, so it is always stored in a steel cylinder by liquefaction of it. That is, converting SO2 gas into a liquid and storing it at a temperature of minus 10 degrees Celsius and 2 atmospheric pressure. Now, let's see some of the physical properties of sulfur dioxide. To begin with it, with respect to color, it is colorless, odor, pungent, suffocating odor, poisonous, highly poisonous, fatal if taken in a large dose, whereas density is 2.2 times heavier than air. We can easily prove it. Take two jars, one containing KMnO4, that is potassium permanganate, pink in color, other jar containing sulfur dioxide. Now do one thing, just take this jar containing sulfur dioxide and invert over KMnO4, the jar which contains KMnO4. What is your observation? You will notice that the color of KMnO4 changes from pink to colorless. The reason for this was, in the beginning, the jar containing KMnO4 was filled with air. The moment you invert a jar containing SO2, SO2 being heavy will go down and the air will move upward. So, KMnO4 will come in contact with SO2. So, there is a color change from pink to colorless, indicating SO2 is heavier than air. It is highly soluble in water. That is 1 volume of water dissolve 80 volume of SO2 at 0 degree. This also you can easily demonstrate. In this case, we can easily prove it. Take a trough containing water or any vessel containing water and take a jar containing SO2, that is sulfur dioxide gas. Just invert it inside the trough or the vessel containing water. Observe it. What will be your observation? You will find that the water has risen up in the jar, indicating that SO2 is highly soluble. The space occupied by SO2 is now occupying by water. So the water has risen up in the jar, indicating the solubility of SO2. It can easily be liquefied at minus 10 degrees Celsius and 2 atmospheric pressure. Its boiling point is minus 10 degrees Celsius and its freezing temperature is minus 76 degrees Celsius. Now let's see some of the chemical properties of sulfur dioxide. To begin with it, let's talk about combustion. Sulfur dioxide is a non-combustible gas and do not support also combustion, but very reactive metals like potassium or magnesium, it continues to burn in the presence of SO2 gas. The question is why? Even though it is a non-supporter of combustion, then why is it burning? The reason for that is the heat of the reaction of the metal is enough to dissociate sulfur dioxide. It dissociates to give you sulfur and oxygen. And oxygen is a strong supporter of combustion. So, a metal like potassium or magnesium continues to burn in a jar containing sulfur dioxide. The reaction for this goes as K, that is 4K plus 3SO2 giving you K2SO3, that is potassium sulfite. Along with that, we get potassium thiosulfate, that is K2H2O3. If we take magnesium, the reaction will be 2Mg plus SO2 will give you 2MgO plus S. Not only that, there will be some amount of magnesium sulfide also formed along with MgO, that is MgS. In case of sulfur dioxide, it is acidic in nature. Now what do you mean by that? If we take sulfur dioxide and introduce in water, that means we form aqueous SO2. It will give you acid, that is sulfurous acid. H2O, when introduced in SO2, or you take SO2 gas and pass in H2O, you will get H2SO3, that is sulfurous acid. Sulfur dioxide dissolved in water, giving you sulfurous acid, which ionizes to give you H+. Presence of H+ indicates the acidic nature of sulfur dioxide. Not only that, this sulfur dioxide is also called as acid anhydride of sulfurous acid. Now what is acid anhydride? Anhydride is the oxides of non-metal which dissolve in water to give acid. Now this acidic nature of sulfur dioxide can be proved by reaction with any alkali solution or carbonate solution or basic oxide. Let's take an example and understand this. To begin with it, we take an alkali like sodium hydroxide, 2NaOH plus SO2 gas when passed through it will give you sodium sulfite, that is Na2SO3, which is water soluble. Along with that we get water. Now take the sodium sulfite along with water and pass excess of sulfur dioxide. It will give you sodium bisulfite, that is 2NaHSO3, which is soluble in excess. If we take calcium hydroxide, which we call it as slake limed, pass SO2 gas through it, we'll get calcium sulfite, CaSO3. CaSO3, a precipitate which is insoluble along with water. It's an insoluble normal salt. But if you take this precipitate of calcium sulfite along with water and pass excess of sulfur dioxide, it will give you calcium bisulfite, that is Ca bracket HSO3 outside the bracket 2, indicating soluble acid salt. It becomes soluble. If we take any carbonate such as potassium carbonate K2CO3 and pass SO2 along with water, that is 2SO2 plus H2O, will give you 2KHSO3, that is potassium bisulfite along with carbon dioxide gas. Another carbonate like sodium carbonate, when treated with SO2 in presence of water, will give you sodium bisulfite, that is 2NaHSO3 along with carbon dioxide gas. When we take basic oxide such as sodium oxide Na2O treated with SO2, we will be getting sodium sulfite, that is Na2SO3. Similar manner, if we take lime, that is calcium oxide, treated with SO2, we will get calcium sulfite, that is CaSO3. Note, the reaction of calcium hydroxide, that is slake lime, can be used as a test for testing sulfur dioxide. When you pass sulfur dioxide through calcium hydroxide, we will be getting calcium sulfite, which was insoluble. The moment you pass excess of sulfur dioxide through it, it will turn colorless, indicating the presence of SO2. On passing sulfur dioxide gas into lime water solution, a white precipitate of insoluble calcium sulfite is formed. But if excess of sulfur dioxide is passed through this white precipitate, it disappears, indicating this solubility. Now, we go to see certain more reactions of sulfur dioxide. We will be seeing the addition reaction of sulfur dioxide. In case of sulfur, it is hexavalent, but in sulfur dioxide, only 4 valencies of sulfur are satisfied by the 2 atoms of oxygen. So, 2 valencies are unsatisfied. As a result, sulfur dioxide shows addition reaction with some of the molecules like chlorine, like oxygen, like lead dioxide. With respect to oxygen, sulfur dioxide, that is 2SO2, will combine with oxygen. It's a reversible reaction, and this reaction will take place only in presence of a catalyst, and the catalyst which we are using is vanadium pentaoxide, that is V2O5, or you can also use platinum, and the temperature which should be maintained is 450 to 500 degrees Celsius. We will be getting sulfur trioxide, that is 2SO3 along with heat. Similar manner, if we take chlorine, dry chlorine, with sulfur dioxide in presence of sunlight, it gives you a compound called sulfuryl chloride, that is SO2Cl2. With respect to lead dioxide, PbO2 plus sulfur dioxide heated will give you PbSO4, that is lead sulfate.